Assalamualaikum and hi. In this video, we're going to look into a new subtopic. So, in previous video, if you look and watch the video, you will see that we already cover full of our 4.1. Wait, I want to change the color. Okay, now in this video we're going to look onto our subtopic 4.2, which is under mission instructions and characteristic. What we're going to look is elements of missions instruction, instruction representation, instruction type, number of addresses, and lastly the instruction set design. So without further delay, we're going to look what next. Okay, in these pages you can see that it's just the descriptions on the elements of your mission instructions, what is available, like over here the operations of the processor is determined by the instructions that executes. So it's referred also as a machine instructions or a computer instructions. The collection of different instructions that process can execute is referred as to the processor instruction set. And each of the instructions must contain the information required by the processor for executions. So better we look into the examples and etc. Okay, this one is the elements in the mission instruction. You're going to have your opcode, the operation codes, or the short form is opcode. You also will have the source operand reference. You will also have the destination, which is result operand reference, and the next instruction reference. Let's say, okay, you will see the descriptions, which is the details of each on the elements. I give you the example. Let's say you have like a move and EAX, and you have, let's say, 100 hexadecimal. So this is the source operand reference, and this is your destinations. I guess this one we already looked several times, and this is your opcode. So you have the result operands and also your source operand. Basically it's an operand, only that this is the destination and this is the source. And for the next instruction reference, normally it's going to be like you have maybe jump to loop or whatever that you're going to assign the instruction to be next. After this what happened? So it's called as a next instruction reference. It tells the processor where to fetch the next instructions after the executions of the instruction complete. After you already execute it, where you going to go? Okay, this is the example part of your assembly language. Of course, you're going to you already familiar with this kind of codes, part of your language, which is assembly language. Then what happened over here, uh, on your left column, you can see this is your opcode, your operations. Opcode also is your operation codes, and this part is your destinations. Okay, this part is your destinations. It's still operand. Another one is also operand, but this one is the source. You have the source, you have the destinations. Same goes to here. You have opcode, you have destination, you have source. You have destination, you have source. Until this lines also similar. So you have also different kind of operand. Later on you will see about 6 of type of your operands. So here, this is the example of your source operand with immediate value, which is you have the value which is already mentioned here directly, which is immediate, you get from this value and you're going to put into your register. So it called as source operand with immediate value. Later on you will see what is this. This is source operand with what? Is a direct, or maybe it is immediate, or maybe it is a register call, and there are several. Later on you will see, right? Okay. Next is under your source and result operands, which is destinations result, can be in one of these 4 areas. Whether you are putting this source and operand in your main or your virtual memory. Normally this one is memory, for both must be a supply, or you are putting it, you are storing it to your register, or you have also immediate operand, the one that we already looked at previous slide. And you can also have input output device for your source. Let's say you can see you have instruction specified the input output module and device for the operation. So you need to key in the value to be fit to your stack. Okay, this is example number 2. You can see over here what is available. This one is your okay, for first time, this is the first instructions. So this is the first instruction. You have move AX total. So this total is basically you already declare on top. Normally you will feel like total equal to let's say 1 to H. So this total value will be stored into your memory. So you're going to store into memory. So this is the type of your operand, memory. And you're going to see you also can have the operand in terms of your register. This is register. You can also have operand with the immediate value. You can have operand with the reading from the input. You can see read from your input. You call as the read from your input. Anything that you key in is going to be the value. So this one is similar like a register, and this is from your memory, and this one is the next instructions, which is what next instruction you going to go, which is go to the target. So you look into the flow, you have 0001 until at the end, which is 007. Basically for next instruction is going to be 0008, but this instruction instruct you to go and jump to the target. So whereas your target is up there, which is you going to start at 0003. So it will be looping until here. That's why your next instruction will be 0003 instead of you going to go to 0008. Okay, this is example number 2. Now you can see over here you have a instruction representation. How you going to represent your instruction in terms of the format? The instruction is represented by sequence of bit. Of course, you're going to have bit by bit that divided into fields. First, you divide it into opcode. Then you're going to divide it into operand. Next, you're going to divide it into operand also. But this one, of course, like source, destination, and then you have the operations. This example is for 16-bit. So depend on how many bits that occupy for your instructions. Okay, over here. Is it difficult for the programmer to deal with binary representation of your machine instructions? Because you cannot understand, right? So is it difficult or you can easily do it? Thus, it has become common practice to use symbolic representations of machine instructions. So you're going to use the symbolic representation for your machine instructions. If your machine's doing add, then it's going to be similar, which is represent the symbolic meaning for your operations. It's called as opcode, are represented by abbreviations called as mnemonics that indicate the operations. So you can see it's called as also mnemonic and it's indicate the operation. Operation additions, operation subtraction, operation multiplication, operation division. So you can see it's quite similar with the exact words for the operation. Okay, this is the example for you when you have the instruction code. Let's say over here you have the instruction type. What is the type for your instruction? And you're going to see over here is load MQ MX. Okay, you can see load, which is load data from memory. So in this example is use load data from the memory. It is using a data transfer. And what is the processor CPU see? The CPU will only see the machine code, of course, machine language 01110 depend on what is basically here. And this is the one that you as the programmer see. Going to see load MQ M and then you have the bracket X. So this is symbolic representation, and what is the meaning by this is transfer the content of the memory location at X to the register of MQ, your source and your destinations. During the instruction executions, when you want to execute, basically what happened when you do executions for your source code for your programming, an instruction is read into the instruction register. So this is what happened in the processor. So the processor must be able to extract the data from various instruction fields to perform the required operation. So your processor need to you need to have the ability to instruct the data from the various instructions. Let's say instructions mentions you to track from your memory, then you can able to do it. There are several instruction type. So you can see there are several instruction type, of course. Consider a high-level language instructions that could be expressed is a language such as C. Maybe you have a C programming. Okay, this is example of your C programming. You in a words, you're going to be total up the total plus stuff. You're going to do the additions process for your stuff and also your total. In term of your C programming, this is your source code, one single line only. A single C instruction may require you 3 machines instruction. This is typically of the relationship between high level language and the machine language. As you know that if you have machine's language, you're going to have fewer line of codes if you compare to the assembly language and also your machine's language, of course. Then in your assembly language, basically what happened? First, you need to load the value of the total. Load the register with the content of memory. So maybe you're going to put load. Move also can. It's depend because you can have variety way for you to do the coding, and then after that you have additions, which is you need to add the memory for the stuff to the register. So maybe you have stuff and you put into your register maybe AX, and you need to store, so you need to move there is no move, which is store the content of your
It's 2
register
hours.
to your memory location for the total. So you need to move your total, and then let's say your register. So it depends. There are several ways. So this is just example. Let's take a look what is the correct terms in terms of the way. So I have basically similar, only that the load over here. But basically you can also use the load because you can load from the education the instructions given over here, declarations, and you're going to load it to your register. Similar. Okay, in English you have please total the tot please total up and assign the sum of your total with your staff. This is in a sentences. And for your high language level language, which is C programming, you have only one single line, which is total equal to total plus staff. After that, you can see when you want to do this similar process in terms of using your assembly language, you need to have several lines instead of just one line in your C programming. So first, you're going to move your total to the register into your memory, and then after that you need to add this total because it's already inside your memory, inside your register EAX. So you need to add the stuff with your total, which is already stored inside. Then you need to move the result. Now is already in your register because you already add, right? So every value in the EAX will be stored to your total. So let's say this is the example in terms of the Intel machine code, how they look. Okay, over here you can see you have several type of instruction. You can have data processing, data storage, data movement, and data control. You can see over here what is data process. Basically, data process is your arithmetic and your logical instructions that use in your code. Under the data storage, you have the movement of the data in or out from your register and also or your memory. And you're going to see the third one is your data movement, which is your input output instructions, and lastly your control, which is test and branch instructions. So the category of your instructions type, they are 4 altogether. This example for your data processing, sometimes the similar opcodes, the similar opcode or operation code, you can also use in different kind of data. Let's say add over here, you can also use in the data movement and so on. I just give you an example. Let's say this one can also be used. I think I have found several, but where is it? I forgot where. Okay, now we look. You can see you have that data processing. Under your data processing, you have several instructions like your arithmetic, which is your mathematical operations. You have also your logical. Then these two is under your data processing. Please try to do all these instruction, play around in your Visual Studio. And then this is under your data storage and data movement. So you can see you have data storage and movement, which is you can use the similar opcode. to represent. Let's say you want to store and maybe you want to move, it's similar. And you can see you can also push the operand into stack and etc. There is a lot of instructions, although sometimes it's not listed here. Maybe you can try to find out what is others of code that available. Lastly, you can see that you have the control which is under test and branch. You have a jump, you have a call, and all other which is under your control transfer process. That is all 4 type of your instructions. Now you're going to look into one by one, but this one is under your number of addressings, which is another subtopic. Under your number of addressing, one of the traditional way in describing processor architecture is using number of addresses, which is contained in each instructions. So you need to know also what is the maximum numbers of address one might need in an instructions. So how you going to define the maximum number of addresses? It depend also on the size of your variables, of your operands. In the most architectures, you can see most instructions have 1, 2, or you can also have 3 operand address in one instructions line. Oops. Okay, let's take a look at several examples. So you were given this equation. These equations, which is you need to execute y equal to a minus b divided with c plus d times e. So if let's say you are having the mathematical form, of course you need to do in the bracket, and then after that the multiple or also divisions, and after that the lower parity is plus and also minus. But in terms of programming, you're going to see in the term of line by line of instructions program. Let's say you can have 4 instructions. You can also have 6 instructions. You can also have 10 instructions. You can also have 8 instructions. Different instruction totals of instructions going to be different in also your variables, your opcode. So over here you can see you are using only 3 address instructions, and this part you use 2 address instructions, and over here is 1 address instruction, and this one is no address instruction. This is your operand. You can see you have 1, 2, 3, but you need to occupy 4 instructions. You have 2 address instructions, your operands, and over here only 1, and this one some have but some not. Okay, you look one by one under 3 address instruction. You can see first of all you have first operand, and then second operand, entered operand. What is all this meaning? Normally you look only two. Let's say you have move A, B. This one will be your destination, this one will be your source. So you will just move A to your B. So this one is just example. If you have 3, what will happen? If you have 3, so if you have 3, this source value basically will do the operations in whatever instruction given. If it is additions, you're going to add C with your B, and then the value of total up C and B is going to be stored into your destinations, which is A. Same goes what happened here. You're going to see you have sub YAB. So you have subtractions, which is you need to sub your two opcode. You're going to sub A and B, and all this value you're going to store to your Y. And then you can see you have multiples or multiplications. You have 3 also. You're going to multiply D with E, and the answer will be key in and store into your T. And you have 8 additions. T plus C, you're going to store into your T. This T is coming out from the value previous T on your operations of multiplications. Serabut dah kat situ. Okay. Then last line, you have divisions. What you're going to do is you're going to divide Y divide with T. Then the answer you're going to store to your Y. So this is the add instruction. So you can see over here, if you compare this instruction with the equation, you're going to see first you will do the A minus B, and then you're going to put to somewhere, it's called as Y, let's say. So what you will get is now at the first line you will get Y. Then this one you're going to multiple, so you will do the multiple with E. And okay, and over here, okay, I delete first, wait. Okay, and you can see the third one. For the third one, you have add, which is T, you add with C. T plus C. And lastly, you have the same T. Okay, this one. Sorry. Okay, this one is going to be T. D multiple with E. So after that, here you can see I'm going to add this T with my C. So what happened now? I already have Y equal to, I have Y, and another operation I have D plus multiple with E, and then this will be as a t and plus with my c. Now I already until the third line. At the fourth line, I'm going to have the divisions. What I will do is I'm going to divide my y over here. Okay, before that, this all, you can see t plus c is going to be another new t. So this divisions is y divided with t. So you will get all together y divided to t. My t will be d multiple with e plus c. So it's going to be similar, only that now I'm going to show my y over here. Y is equal to a minus b, and then my t over here is d d d multiple with e add with c. So it basically similar to this one. Now you have another example. You can also have two address instruction. Aduh. Sorry, wait saya kena betulkan tulang saya ni sikit. Tulang saya bengkok ni, tulang belakang. Okay, so over here you can see you have two address instruction. You have destination, you have another one is your source. You need to do similar thing. So now you move a into y. So the value of y now is a. You're going to sub, for the second one, you're going to sub your y with your b. You're going to subtract your y value, which is y now is a. You're going to sub with your value of b. And you're going to store it to your new y. So my new y is a minus b. And then you're going to do move. You have another one which is t. You're going to move d into t. Now your t is equal to d. Next is your multiplication. You can see you will multiple e with your t, and your t now is d. You just need to multiple it. Because after that you're going to store back to your t. This is your new t. The what line? 5. Fifth line, you have additions. You can see over here you need to do additions. You're going to add your t. This is your new t. You're going to add with your c. And you're going to store to your new t. Then you're going to get here. Last line, you're going to do division, which is your y. This is your y, which is a minus b. And then you're going to divide it with your t. This is the value of your t. So you get similar to this one. Aduh, nak duduk macam mana ni sebenarnya? So itulah, waktu saya muda-muda dulu saya sangat aktif Dan tiba-tiba tak tahu kenapa tulang saya dah bengkok dah. Next, we're going to move to one address instruction. Aduh, tak tahu nak duduk mana. One address instruction, you can see the example, you need to have add instruction. So I guess it's quite similar also. What is happening, you need to load D. So your D over here, you're going to load and you're going to put it into your register. It is not mentioned directly, but everything that you did over here, you're going to put and store into your register or also your stack. Usually the CPU register or a accumulator. So supply one operand and store result. One memory address used for other operand, commonly early machines. So you have D now. Let's say in this example, we store it at the AC. So now the value is D. You're going to multiple this one with your E. And you're going to add after that the value with your C. These all you're going to store to Y. So now it will be as a Y. You need to load another one, which is for CAC, because this already be as a Y, and new one you're going to load into your register. The value is A. This one, right? This one, after that, you're going to subtract with B. Just subtract it. And after that, you're going to see, you're going to do divisions. What will happen? This one, you're going to divide with Y. What is the value of Y? You just put this back below. And last instruction is store. Store all the value, this one, into Y. So you will get Y equal to all of this, which is the Y is going to represent like this. Okay, so you have 0 instructions address. Maybe I guess this one you can also try by yourself. It is just similar. If you didn't know, then you can try to just copy all this code and try to do step over in your Visual Studio. Wait, I need to correct my positions. Okay, please try to do this example, which is under your no address instructions. Now we're going to move another sections, which is on your stack machines. What will happen basically when you are key in any kind of variables, any kind of your operand, any kind of your value, you're going to store into your stack. A stack is an abstract data. So you have type data structure based on your last in first out, which is LIFO. This one I already explained several times. What will happen I give you a different example. Let's say you going to key in data. So when you want to type into your computer, you're going to use your keyboard. What you will do is you will key in and type D first. So your D, you're going to have a stack. So D will be coming in first, and then second you will type A. Then third you're going to type T, and after that you have A. So this is how you're going to put into your stack. And using the LeFo principle, how you're going to take it out, which is this is whenever you have key in something, you call it as a push. You push it into your stack. You push it into your stack. You push it into your stack. Now when you want to come out, you call as a pop. Going to pop the last in. This is the one that last in, and this will be the first out. So this one will be A, second will be T, A, and D. This will be using principle of LeFo. Okay, this is a long day because I have a class from 8 in the morning. So that's why if I have straight class, I need to have quite a long gap because I cannot sit down in a long time. So I will having very much pain in my back. Because tulang belakang saya ni dah bengkok kan. Dan saya tak pergi pun buat fisio ke apa, biar je lah dia macam tu, nak bengkok ke nak apa. Tapi in term of kalau nak cari kerja hari tu, bila kita scan tu memang nampak lah tulang belakang tu bengkok. So doktor cakap, what happened? Apa yang berlaku semua. Saya pun tak sedar masa bila dia bengkok. Tiba-tiba dah bengkok dah. Okay, I continue. So, where you're going to apply this principle? Later on, you will apply it in your RPN, which is reverse polish notification, and deep first search your DFS, which is we're going to discuss in our next slide. And this one is on your expression of your tree. If you have equation, you can express it in terms of your tree expression. So this one is quite easy. I think it's quite easy because it's like a normal mathematical form. So if you have a multiple with B, then what you're going to do is you have the child, and then you have a parents. This is the parents, which is your operation, but normally I will always love to do variables. This is variables, this is operation, this is variable. So you have like this. And if you have this, of course in your mathematical term, you're going to have the bracket first. This is the first priority. Until below, you're going to have multiple and divisions and subtraction, additions, and your subtraction. This one is divisions. Okay, now you can see over here, you firstly will do this part. Then you draw A, B, you have the parents of multiplication, you connect them together. After that, you have another parents which is plus. Alamak, nampak macam sama pula. This one is plus, this one is multiple. Then you have another variables or operands is C. So over here, what you're going to do first, which is your bracket, of course. First, you're going to do B plus C. Then you have multiplications. E. So it's very easy to draw the expression 3 using a normal form of mathematical. So then the first bracket is the priority. Same goes to here. First you did A, you have a parents of plus B, and then you did also the bracket inside first, right? This is just a mathematical form. D E minus, and you have a divisions. You're going to divide it with your C. Then you will come out and meet the multiplications. So I'm going to move to the expression 3. But now you're going to look into the infield notification. Infield notification is quite similar with your mathematicals. It's not too hard for you to understand it. You're going to use left parent right order. So in this example of equation, you're going to do and apply left parent right. So the left is normally your variables, your child, and then you're going to have A left, and then you find the operations, which is multiplication, and then the right is your B. So when you have the complete order, what you will do is you're going to do again, repeat it, and this one will be your left one now. This will be your left one now. Then you have left, and you meet your parents, because you can see you done this part left parent right. After that, you meet the operations. So what you need to do is this is left, and your parent, you just copy it, and you have the right of variables, which is your C. So that's why this will be in a bracket. This is the first floor for left parent right. This is in terms of infix notification. So if you see over here, this is the example. What happened? A x B multiples multiplications, and then you have plus, and you have C. Next is the example for your postfix notification. You're going to do all the operands, all your variable first, and then you're going to meet the parents, which is left, right, parents. Parents is after your variables. You're going to store all the all the operations into your stack before you're going to use the LIFO principle. This is the first example. A multiple with B plus with C. So first of all, you're going to do left. A is your first variable. After that, you meet the operations, which is your multiplication. So you will push it into your stack. You akan simpan dulu. You're going to store it first, because the parents will come later after that. Then you will go this flow from left to right. Your right now is your B. Then you put your B. Because you already find another one, you come out over here, there is another operation. So you need to stop first. You're going to do pop, because you meet a new operations, a new parents. So you will just stack pop the parents that you already store. And you're going to continue. You're going to continue. This one, after you pop up, this one will be stored into your stack. Now your stack will be having your plus. And you will go flow and you will meet the C. After that, there is no and nothings. So you need to push a pop up back the additions that you already store in your stack. Now you will see this is your post prefix. How you're going to see is from your left to your right. And until you go to the right, then you will go to your parents. And from your parents, you go to the from left to right also. This is from left to right. And after finish, there is no until right, then you go to the parents. So if let's say there is a D, let's go until D, F, go until F, then you will come out to the parents from left to right. Same goes to over here. Let's say you have another C, A, B until C. Then after that, you're going to go up to the parents. Depend on your equations. So we look another example. So then you're going to be understand is more. This one is just detail first under the reverse Polish notification, which is RPN. This one that you're going to apply your LIFO inside. You can see, observe the parentheses are not necessary in the postfix notification. Called as RPN, which is reverse Polish notification. In a reverse Polish scheme proposed by FL, oh I like FL name, and EW blah 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 blah, in the early of 19th century, after 1 decade, to reduce the computer memory access and utilize the stack to evaluate the expressions. So apa maksud panjang-panjang ni? So this one is the reverse Polish notification, and this you're going to apply your LIFO. What is the purpose is for you to And in the beginning of 1915, this person observed that parenthesis is not necessary for POX notification. So it's not necessary. And this Polish reverse scheme also then later on will proposed by the FL in the early 16th centuries to reduce what is the purpose which this one. So let's take a look into example. You have the RPN, reverse police notification, and you're going to convert it into your postfix order. The example is here. This is your infield equations. So you have left until right. When you meet another parents, then you're going to stop and put it into stack. Okay, we do it one by one. Left 1, and then you meet this one, your operations, you're going to store it into your stack. Until to the right, you have 5. This one already finished because you have this bracket. What you need to do is from left to the right, and you will move to your parents. Same goes to whatever happened later on. You're going to move from left to the right, because it's basically difference from left to the right, and then you're going to move to the parents. Okay, then over here, what happened is this one you already store, right? And you meet another new operations. Before you going to store this one, because it's another new operation over here, you going to pop this first. When you pop this, you will put it here. And because you meet this one, you're going to store at your stack. And from your left to the right, you're going to finish all, because it is in one bracket. You're going to finish all the variables from left to the right. You will meet first 8. After that, you meet the parent, which is operation. You're going to push into your stack, and you're going to meet your another bracket. You can also put it here because you're going to store another one, but it's okay because you're not going to put it as the equation. Then you meet your 4. After you meet your 4, you meet another operation. You're going to store it into your stack. Then you meet 1, and it's already finished. This bracket you can also put it, but until the end of the brackets of this one operations. So you already done. What will happen from left to the right? After that, you're going to do a parents. What happened when you have the stack? You're going to pop this first, and then this one is second, and this will be come out last. So you will be getting the similar postfix like this. And why you need that? Is it the similar? When you have this one, you have 6. Sorry. You have 6 multiple. This one is 8. You have 3, 6, 5. You will get 30. So from that 30, is it you going to get similar result using your postfix? This one is your mathematical tree. What happened? You will add, you will multiple and so on. But in your postfix, what you will do? First of all, how you going to store it? This one you will key in all into your like register stack. So you will first meet. It's going to be like this, right? From left to the right. This is your normal when you are reading some things. So first you're going to push. This is your stack. First you're going to push 1. And then you're going to push 5. When you meet operation, you need to call the pop. After you push, when you meet operation, you're going to pop out. What happened to pop up? You take this operation plus you're going to put it and add these two variables. Then after you already pop all the variables, because normally it's going to be 2 only, because this is operation. Operation will just occupy 2. Then your current stack already empty, because this one is already come out, this one is already pop also. Now your new stack is empty. You will do this operation first. You will get 6. This value you will push. Before you continue, you're going to push first into your stack of 6. And then you continue read your postfix equation. You meet 8, you will push. You meet 4, you will push. And after that you will meet 1, you will also push. But then you meet operation. Operation, what you going to do? You're going to pop. So this is your operation. 1 will be popped over here, 4 will be popped over here, then you will get 3. Your current stack, you have 6 and 8 only. Then you have this value, you will be push first before you continue, as I mentioned, right? Before you continue, you're going to push. Now you have, alamak, kat mana nak tulis? Now you have 6, 8, 3. And you will continue, you meet another operation. If operation, what you going to do is pop. Macam pop quiz pula. What you going to do is pop. And your pop operation is minus. You will pop the 3. You will pop the 8. And 6 will still remain there. This one will be getting as 5. What happened to the value? You're going to push before you continue. Then you're going to store this 5 over here. After you already push, you continue, you're going to find X. This is operation. What you're going to do after you go mid operation? You're going to do pop. What operation is a multiplication? You have this. You pop. You poop pula. You pop and you pop another one. What you going to get? 30. Now your stack is empty. What you going to do with this value? This value will be pushed into your stack. When you have one value and there is no equations or representations, anything over here, then it will be your final answer. Similar, right? So in terms of the example from the slide, you can see you need to scan from left to right until an operator is found. Then the last two operand must be retrieved and combined. Order of the operand satisfy the LIFO, so we can use stack to store operand and then evaluate RPN expression. This one in the infix and this is in a postfix. You have also evaluation of your RPN expression in terms of flowchart. So you can try to look into it and read it one by one. And this is the example which is similar what I show you in terms of interactive way. So you have first is 1, 5. You're going to store first your 1. You can see over here. Going to store your 1. And then your second is 5. Going to store 5. After that, you're going to meet your operation. If you meet operation, what you're going to do? You're going to do pop. Your pop, you're going to do additions because it is a additions. Then you're going to take it using LIFO. So 5 will become out first and then 1. This answer, you're going to do what? You're going to store into your you're going to push and store into your stack. So it's going to look like this. And I'm not going to make you confused by continue below here. What I want to see is after this operation, you have the value of 8, 4, and 1. One by one, you will be push it into this stack. Okay, let's see it. You have 6, and then you have look up. Okay, look up in this instead of below here. 8, and then you have 4, and another one is 1 until over here. Now the next, you're going to meet the operation. You meet the variables, which is your operand. What you're going to do? Push. When you meet operation, what you're going to do? Pop. Now you meet the operation. You're going to come up 1 and second one is 4. So let's take a look the example. So you already take it out 4 and 1. So you get this answer. This is inside your stack. So this answer you will push before you continue, right? You're going to push into your stack. So that's why you will get like this. It's going to be at the back, and previously it's going to be in front, just because of your step. Then you're going to continue. Next, you will meet this operation again. So this is your stack, and when you continue, you're going to meet another operations. Same goes below. You will do what? Pop. When you do pop, then you can see you have you can get the answer. What you're going to do? You're going to push inside your stack. After you already push, what you're going to do is you need to continue. Next is you're going to meet also the operation. So existing, your stack will have 6, 5. When you meet another operation, which is which is your multiplication over here, what you're going to do, it is pop. You're going to pop the value 6 and 5. You get the answer. What you're going to do with this answer? You're going to push. Then it's going to be inside your stack. You check again. You move from left to right. Is there any other variables or operand or operation anymore? If there is no more, then if your answer is only 1, it means as the final result. Okay, you can see it clearly, and I think it's very simple for you to do. Now you have another exercise. I forgot to what? Where is it? Wait, okay. Did I already unhide it? Okay, already. Okay, from here, you're going to do the post-fit evaluation. What you're going to see? Or you go... Okay. You... Wait. Okay. You're going to do your exercise 4.1a. Okay, this exercise, you can see you have A plus B, and then you also have multiplication C minus, then you have your bracket over here, and you have multiplications with G. So you need to construct first on expression of 3.
It's 3 hours.
Tak ada gambar 3 pula. You need to draw the 3 first. So when you have the 3, mana I boleh delete Tak ada delete. Because I already saved it previously. So from here, you have the expression of 3. What you going to do? You're going to do, let's say, A, B plus, and then you have multiple with your C. So this is this side, and you're going to see you have another D, E multiplications, and you have F, plus F. All of this you're going to do the multiplication with G. Now you're going to have these subtractions over here. So this is the expressions of the 3, normal expression of 3. If you want to change it into the postfix, what you're going to do? You're going to do from your left to the right, and then you're going to do you're going to go to the parents, and from the left to the right, and you go to the parents. So what is happen over here when you have A plus B and then you have multiple of C? If you look at example, postfix example, you have A plus B multiple with C. As I mentioned, if you have everything over here without a big bracket, which is divide it with a big 3. Let's say over here, this is a big parents, this is a big parents. You going to do directly from left to the right. Okay, from left to the right, what you will see? You will meet A. And then next, you're going to meet your plus. So this is your stack. You will store your plus first. Then you meet your B. After you meet your B, you're going to meet your multiplication. You're going to store it into your stack. And to the right again, you have the C. So you finish all from left to the right. Now you're going to do your parents. So you're going to go to first, this will come out, and second, this will come out. So that's you're going to get if you have infix of A plus B multiple with C, you get A, B, C multiple and plus. Same like this. Okay. Then you can see over here, same goes what will happen over here. You have A, B, C, and then you go to the parents. Later on, you will meet over here. This one also you will do similar things. Okay. Dah conteng-conteng sini tak nampak sangat Okay, I delete first. So we will see the next example. If you have A multiple with B plus C, what is different between this one and this one for up and down? So in your mathematical, you going to have different tree. For A plus you have B multiple with C. A, B, C, and then you will go like this. From your left to your right and then to the parents. This is the example from this one. Oh, basically it's similar to this. I think there is a part that I made some mistake, which is I put A plus B. Because normal infield, you going to see the normal mathematical form, you will do the parity first. Any parity will become first. So at below over here, you have the parity of multiplication. Then it's going to be A multiple with B. Then you have the 8 of additions buttons with C. So totally different kind of tree. Although it looks similar, you just change the place between each other, right? But you will come out with different kind of tree. Oops. Mana dia? So, what will happen over here? So, you're going to do left to the right until you cannot go to the right anymore, because this is 1. Then you will come out first to your parents. When there is a parent, you're going to go to your right. And it's go back to a parents again. So that's why you will get A, B, multiple, and then C. Okay, in term of this one, in term of your tree, how you going to see in term of your equation, in term of your expressions? So you will do A, B from left to your right. You have A, and then you have multiplication. So this one is the parity. It's going to be parity first. You put this multiplication into the stack, and you meet the B over here. After that, you're going to see that after your multiplication is the plus, so it's not going to be a parity. Then this one will be coming out. So you're going to continue. You will meet this plus. You're going to store it, and you will meet the C, because from left to right, right? Then you have the parents. You come out again to be here. The third example, you have bracket, bracket, bracket. So you're going to come out with a kind of tree. A plus B. Then you have another bracket, C minus D. In between you have multiplication parents, and you have another bracket. You have E, F plus. This one, going to combine it together. This one, going to combine it together. And you have the multiplication. Division, sorry. Division. over here. So you will do like this. Okay, if you look into from your left, right, and then parents, left, right, and then parents, then you go to left, right, and then parents, then you go up straight to your parents until you meet the parents of your side over here. Then from here you have E, F from left to the right, and then parents, and then parents. That's why you will get A, B plus C, D minus multiplication E, F plus divisions. So how you're going to do is basically when you have this kind of parity, you will do A like this, right? B, you will store this into your stack. But you will see that this is your parity. After that, you're going to see it is a multiplication. One parity, you're going to come out and pop your operation. And you will continue. When you continue, you will see that you find this multiplication. You're going to store your multiplication, which is you push into your stack. Then you're going to meet your C, and then you meet the operations of subtractions. You store it. You have 2, 1 and 2 now. And you move again from left to right, you will meet D. This one is another bracket, another process. So you're going to stop it until here, because this one will be stored, but you're going to put stop. Then you will see what you're going to do is you will pop up this value negative and this value of multiplications. You're going to continue. First, you're going to see you will meet. Now your stack will be empty, right? You will meet your divisions, and then you're going to meet your E, and you meet your plus. You store it into your stack, and you meet your F. Then you meet another bracket. When you meet another bracket, what you're going to do, you're going to push it out, plus, and then divisions. So please try to do it until you can see what is basically happen. So same goes to your question over here. What you need to do, I delete first, okay? Cannot delete. Okay, now okay. What you going to do, you have A, B multiple with C. This one similar to your example over here. So you just bring it out again. A, B, C multiple with plus multiple and then plus. So you will come out with this one. Now you will have you already finished this part, right? Then you're going to move from left to right. You have the value of operations. This you're going to put into your stack. You meet the D. When you meet the variables, you're going to come out, which is going to push it out. And after that, you meet another operation, which is your divisions over here. So you're going to have the divisions. After your divisions, you can see you meet another operation, which is your plus. What is happening? This one is lower from your multiplication. You're going to do this first, right? So each same also like in one operations, one process. That's why you will come out with the E, because you already store the division over here. You can see you already store your division over here. So you're going to push it. So from here you're going to continue. You're going to continue. You're going to meet your plus. Your plus now you're going to be store, and you have the F. That's why you will come out the F after this over here. And when you meet another bracket, which means that this is one operation, you're going to stop. What happened when you stop? You're going to do the poop. You're going to do pop. So you're going to pop this one. This one you store because this is another operation at this side. So because you have another operation at your left, then you not going to take it first. After this, you can see you're going to meet your multiplication. You're going to put it here, and your G. Now when you want to finish, because there is no more, going to pop up everything. So this is how the way. And if you see in the example, you will see that you have also stored the bracket. Then all this bracket means that you're going to stop. You're going to stop because your bracket will put it here, and you cannot come out the minus. That is why it's going to be easy for you to see. But I just show you in terms of my explanation. You can also follow this example where when you meet, okay, this one is already done, right? This part is easy. When you have you continue, you will meet negative. You're going to store here, and you meet the bracket, you're going to store again in your stack. Then you will continue, you will meet the D. When you have meet the D, you meet the multiplication divisions. You're going to store it here. After your divisions, you will meet your E. That's why you will come out to here. After your E, you meet another operation, but this operation you can see it is below than this one. So you will need to pop up this, because the parity is at the multiplication. So that's why it will pop up first. Then you're going to restore your new operations. You're not going to come out this first, which is your subtraction, because you have the bracket over here. Then when you come out your division, you will store your plus. Then over here you meet the F, and you meet the bracket. Your bracket you will be store. Macam mana bentuk dia sekarang? Under your stack you have minus you have a bracket, and you have plus, and then you have bracket. You meet the bracket now. So before you will put it into your bracket over here, you're going to push it first. See, you're going to push it first before you push the bracket inside your stack. So this will become out, and you're going to push your bracket here. After that, you will see you meet another one, which is your multiplications and your G. Now what happened is you will pop, because there is no more operations, and all the bracket you will remove and put the subtraction, the last one over here, because you're not going to come out it before this, because you have the bracket operation. That is what is represented on the example. So you can also try to do exercise number 4.1. Over here you can see you have 4.1b. You have a plus b multiple with bracket c minus d. So first of all, what you're going to see, you have the bracket, but bracket below over here, nothing which will happen, but you can also just store it, and you have the value of your a. After you have your a, you will meet the plus, so you will store your plus first, and you're going to come out with your b. So this b, and you're going to meet your bracket. Because of your bracket over here, you need to stop and take it first from your stack. So this will be taken out, and you're going to show another bracket. Now what is happened is your bracket only, so it can consider as empty into your stack. After that, what you're going to meet is multiplications. And you meet the bracket, and you meet C. So over here you have the C, and you meet another one is your minus, and you find the D. And before, you can see, after that you have this bracket. Before you finish this bracket, you're going to do pop. So you're going to pop this value. So when you already pop, then you're going to store this one, which is your bracket. But before that, you can see this is your operation over here, and between these two, you can see you have another bracket which is going to pop everything here. So you're going to pop the multiplications, and then you're going to continue with divisions, and then you have E plus F and G. So please try to do the rest. So what is basically happen to your EF, and then plus, and then division, and so on. So there is also a exercise 4.2. Please try to do it, but this one you need to do it in vice versa. You were given the postfix. You're going to give in term of vice versa. Kenapa I reverse? Okay, this one. You can see there is a several example before you can come up into your exercise 4.2 A, B, C, D, and E. Let's say you have example of your postfix. Your postfix is A, B plus C, and then there is a minus. Normally, if you have this one, you're going to do one by one, which is you will see ya Allah, kenapa tak bergerak ni. Tak nak naik atas. Okay, you will see that normally you have the minus. This minus will be your this one is one operation, and this is another operation for your big parents. So what I will do is I'm going to do A, and then I'm going to put space between two variables. There is a space and then B. When I go in and I meet an operations, I will know this operation is for something in between. So I will put plus over here. And I will go again. You can see I will put space first, and then I will put C, the variable that I meet, and then the operation. This operation will be between, so it will be putting here. So this is the example how I will convert this ABX plus C minus to the infix again. Example number 2. I tak tahulah mouse I ni kenapa dia tak gerak-gerak. Okay, we have AB plus, later on the rest you're going to do by yourself. Okay, you have AB plus CD minus multiplications. You have A, B, and then what you meet is your plus. So you will put between, and then you have C, and then you have D, and you will meet the minus, which is for between of it. Lastly, you will meet 1. So what you're going to do, you're going to give in a between of these two. Is it correct or not? Yes. Try to do another example and also the solutions. So now we're going to look into our addresses. I guess I need to stop first the video because it's already too long. I will continue in a next video. It's okay? In our many addresses. So thank you for watching this video. Please look into next video for you to understand and look into our next subtopic. Thank you and bye bye.